Okay, guys, we're going to do another triangle center today. It might help if I move the camera. I'm here. Okay. We are doing another triangle center. We're actually going to do all the notes today, but not all the homework today. So we'll come back on Monday and do some more of the homework, which will allow you to ask questions if you need help on anything, okay? So this on page 66 is 8.2, angle bisectors of triangles. Okay, and we're going to label 67 the same thing. All right, and all the notes today come from your book. You need to tear out page 372, 374. So just those two pages. Like I said again, we're going to do all the notes today, but only part of the work today. Okay, from 372, we need most of the page actually. From 372, you need this. It will go glued in on page 66 just like this. So there's that one. And just dropped everything. And this as well. So you need those two pieces. They go on, they're from page 372, they go on 66. I'm going to glue those in while you're cutting them. If I can get my glue stick. Okay, we're going to go ahead and set up the whole notebook page. So now that we've got those glued in, we're going to get what's on 66, okay? I mean 67. So from page 374, sorry, it's going to take me a minute to realize what you need from 374 evidently. It's going to be a very weird kind of cut here. You need this from 374 and another piece, so hang on, I dropped it. And this, so just skip about 2 or 3 lines. Let's move it a little further down and glue it in 4 lines or so. Those are 2 things you need. Okay, so here's what you got. Got this piece, we're going to come back over and talk about angle bisectors of triangles. Okay, so the distance from a point to a line is the length of the perpendicular segment from the point to the line. You will prove the following theorem about angle bisectors and sides in exercises 16 and 17. Not today, but later. You will prove that. The angle bisector theorem says if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. Meaning, if this is congruent to this, because this is the angle bisector, this AC is congruent to BC. That's what it's telling you. The converse is also true. If a point in the interior of an angle is equidistant from the sides, then it is the bisector. Meaning if this is true, then this is bisected. Okay, so we're going to use that. So, example 1 says find LM. Well, they already tell us by these little marks down here that these are congruent. So if this is cut in half, that means these pieces are congruent. It tells us to find LM. So LM is congruent to JM, so LM is 12.8. Okay, I'm going to focus this because it's really kind of grainy. It's still grainy. Okay, example B. Take a minute, pause the video, try that out. In case you wanted to know, this is the angle bisector theorem. This is the converse of the angle bisector theorem. And it says, measure of angle AB, we're supposed to find the measure of angle ABD. So that's what we're going to look for. Given that ABC, this whole thing is 112. Now, since these two are congruent, by the converse, these two are congruent. So, if they're congruent, that means it's going to be the bisector that's cut in half. So, half of 112 is 56 degrees. By the way, I did not make a mistake right there. It is 56 degrees. But there have been videos where I have accidentally made a mathematical error. Bring those to my attention if I do, or you think I do, okay? Now that I said that, I'm worried that 112 divided by 2 is not really 56. We're going to check because, you know, sometimes you never know. You never know. Don't be afraid to make the mistakes. I do it too. Look, I was right. Okay. Angle bisectors now. We've talked about the angle bisector theorem. However, angle bisectors of a triangle create one of those triangle centers. So as you have seen, the angle bisectors of a triangle are concurrent. You haven't seen that yet. I'm going to show you a quick thing that shows you that. Remember, concurrent means they meet at a point. The point of concurrency is called the incenter of the triangle. Our triangle center today is incenter. The angle bisectors of a triangle intersect at a point that is equidistant from the sides of the triangle. The incenter, which is created by angle bisectors, so all of these are cut in half, has a point P that is equidistant from the sides. Not only is it equidistant, they have a right angle created, okay? So, example 3. Let's look at the picture first. They, in these pictures, do not include every single piece here. So we have to think about what's going on because they're not going to create every piece because it gets very messy very quick, okay? So before we even look at what we're solving, we need to think about this. JV and KV are angle bisectors. JV, KV. This means these two are congruent and these two are congruent, okay? Find each measure. Since these are angle bisectors, V is the incenter. That means if we drew a segment from V to L, that this would be bisected. It also means, by the in-center theorem, that each of these, let me get a different color, each of these from V to W, from V to some point we don't know, and from V to another point we don't know, would all be congruent, because the in-center theorem says that the point is equidistant to the sides. So we drew those in ourselves. We can do that. Letter A, the distance from V to KL. From V to KL. Well, we just drew that. It is congruent to V to W, so it is 7.3. So sometimes we're going to have to draw extra pieces. That's okay. All right. B, the measure of angle VKL. VKL. We are looking, I'm going to start erasing some pieces because it gets really messy. That's why I should be doing this in something you can erase. VKL is this piece right here. I have 19 degrees here. This is also 19 degrees. This green piece and this piece are going to be congruent, and I have an entire triangle. That's how I'm going to have to find what is missing, what this angle is. So I'm going to do 106 plus 19 plus 19. I'm adding 19 twice because I need to find this angle and subtract from 180. I'm going to use a calculator because I make simple math mistakes. If you don't, well, that's amazing. I'm happy for you. 144. Now, 180 minus 144, 36, yeah, 36. Now, that does not mean that this is 36 degrees. Half of it is the whole thing here is 36 degrees. I need to know just this half. So I'm going to divide 36 by 2 and get 18 degrees. That is how I find the measure of VKL. You are doing the same thing for this next example. So pause the video and try it yourself. Okay, we're going to talk about what each piece means. QX and RX are angle bisectors. QX and RX are angle bisectors. Find each measure. I know from this in-center to here is congruent to this side length, and this to this side length because of the in-center theorem. Number 8 says, what is the distance from X to PQ? Well, it's the same as X to PR, or the point Y, so it's 19.2. Now my angle. I need to find the measure of angle PQX. I'm going to highlight that angle. I'm going to erase these extra pieces. PQX. Now, a common mistake is to look at this and do 90 plus 52 and subtract from 180. You cannot do that. This is not a triangle. It's a quadrilateral. There are 1, 2, 3, 4 sides. So you can't do that. We have to do what we did before. We're going to add 52 and 12 twice. And we're going to get 76. So we need to find out what's left over for this angle. 180 minus 76 is 104. The measure of PQX is half of 104, so it is 52 degrees. Okay. So like I said, we're only going to do half of the homework today. We'll do the other half when we come back, and then we'll start something else. or next week. I will see you then.